Clapeyron equations. So basically, this is according to the third Maxwell relations, because during a phase change process, which is P at P saturated, which depends on T only, is independent of the specific volume. So means that the that during a phase change process from one phase to another phase, it depends on the temperature, and the partial derivative p derivative t v can be expressed as total derivative dp per dt saturated equals to the slope of the saturation curve on the pt diagram at the specified saturation state. The slope is independent of the specific volume, thus it can be treated as constant during integration of above equation between two saturation states at the same temperature for an isothermal liquid vapor phase change process. For example, the integration yields like this. Okay, so this is the behavior. So we can see the slope is taken, the slope of the saturation curve on the PT diagram is constant at a constant T and T. So this is after integration, then, or it can be rearranged into this. During the process, the P also remains constant. Therefore, from equation 1211, so it says that dH equals to TdS pushing H equals to TS Substituting this result into equation 1221, we obtain dP per dt equals to HFG per TVG. So basically, this is the Clapeyron equation, and the Clapeyron equation enables us to determine the enthalpy of vaporization at a given temperature by simply measuring the slope of the saturation curve on the PT diagram and the specified, okay, this is the PT diagram, and the specific volume of saturated liquid and saturated vapor at the given temperature. So the condition is, this is the general form of the Clapeyron equation, where the subscript 1 and 2 indicate the two phases, or we can derive further as the Clapeyron equation can be simplified for liquid vapor and solid vapor phase changes by utilizing some approximations, whereby at low pressure, so this is we can treat the vapor as an ideal gas, RT per P, and substituting into Clapeyron equation, so we can get the final equation as ln P2 per P1 saturated equals to enthalpy per R 1 per T1 minus 1 per T2 sets. Okay, we have to take note that the Clapeyron-Clausius equation can be used to determine the variation of saturating pressure with temperature, and it can be also used in a solid vapor region by replacing HFG by HIG, the enthalpy of sublimation of the substance. Okay, so by having this formula, so let's move on to the individual exercise. The vapor pressure of a substance is 21 torr at 300 Kelvin. Calculate the vapor pressure at 310 Kelvin if the enthalpy of evaporation is 24 kJ per mole. Explain the trends. Okay. Okay, make sure you upload in the individual assignment, but I will put the link after this. And next exercise is the vapor pressure of a substance is 30 torr at 250 Kelvin. At what temperature will substance have a vapor pressure of 150 torr? The enthalpy of evaporation is 45 joule per mole.